These are the video notes that will go with literal equations, okay? Now, literal equation, we often call a formula, okay? You know, formulas are a lot of times associated with more than one variable, and you have to replace them with numbers, problem solve, okay? What we're going to focus on today is not problem solving, but we're going to be focusing on taking these equations or formulas and solving for a given variable. The steps that you're going to do are the same steps that you have with regular equations. The difference is what we're going to be moving around and combining are different variables and not numbers, okay? So we have 8 examples today to look at. Okay, I'm sorry for having so many examples. I do apologize, but I needed to give you different case scenarios of the different types of things that would pop up for you. So our first example, okay, is going to be U equal VW plus Z. And then behind that, I'm going to have a little semicolon and a V. So what that semicolon and that V tells me is that I'm going to solve this literal equation for V, which means my very last line is going to have V equal everything else. Okay? So what I'm looking at right now is I'm going to isolate my V. Okay? Now, I want you to think about this. This is kind of like 2x plus 4 over here. It's V times W plus Z. If I had like 2x plus 4, we would say, oh, well, we're going to subtract the 4. Well, we're going to do the same process here, and I'm going to subtract the Z from both sides. Okay? Just like that. Now, I know right here with the U minus Z, I really can't combine those because they are not like terms. They're not. So what I'm going to do is rewrite this horizontally, and I'm going to have U minus Z equal to VW, just like that, because we know those Z's are going to cancel each other out. Now, remember in this, we are isolating V, okay? So that means I need to get rid of the W. And since this is multiplying V times W, I'm going to divide both sides by W. So what I'm going to have is V equal to U minus Z, all divided by W. Okay? Now, you can pause your video and copy this down and then restart it for example 2. Example 2 says FG minus 9H equals 10K. And we're solving this one for G. Okay? Now, again, I want you to think about how we solve an equation. I'm isolating G. So the first thing I need to get rid of and move to the other side is the 9H. So what I'm going to do, just like if it was just a plain old number, is I'm going to add the 9H to both sides, just like that. We'll just bring down that FG because we haven't done anything with it yet, and bring down the equals. And we know the minus 9H plus 9H, that cancels out because it's a 0 pair. Now look right here. I need to rewrite this not vertically but horizontally because we can't really add them together because they're not like terms. One has a K, one has an H. So what I'm going to have is 10K plus 9H. Now again, I'm isolating G, so what I'm going to do is divide both sides by the F, just like that. So G is going to equal to 10K plus 9H divided by F. Okay, pause and make sure you've got everything copied down correctly, and then we'll go to example 3. Okay, now example 3 here is R equals 2/3 T plus V. And we are going to solve this for T. Okay, now let's discuss this whole fraction part right here. Let's go back to what we talked about in our equation unit about multiplying by a fraction, okay? Or having those fractions in our equations. You remember we said the easiest way to get rid of a fraction is to take your equation and multiply it by the LCD. In this case, my LCD would be 3. Let's get that right in there. So what I'm going to do is multiply, just using distributive property, everything here by 3. So 3 times R is 3R equal to, if I multiply by 3, divide by 3, we know that cancels out, and that leaves me with 2T plus 3 times V, which is 3V. Okay, now we need to isolate the T. So the first thing I'm going to do is move the 3V to the other side, just like that. So I'm going to have 3R minus 3V, when I just rewrite it, equal to 2T. Now, all I got to do now is divide by the 2. So I can just do T equal to 3R minus 3V, all divided by 2. And I'm done. Okay, pause and copy, and then we'll move to example 4. Okay, now, example 4, again, it's going to be dealing with a fraction. I've got 10AC minus X all over 11 equal to -3. Okay, and we're going to solve this one for A. Now, I'm going to handle that fraction just a tad bit different here because I have the 11 dividing all of this whole entire side. Since it's dividing the whole entire side, which is different than number 3 right here, because 3, only one term had that fraction. Okay, this one, the whole side has that fraction or that denominator. I can just take this denominator right here and I can run it right over here and I can multiply. Okay, so if I do that, what I'm going to have is 10AC minus X equal to, now -3 times 11 is -33. Okay. Now, we're still trying to isolate A by itself, so the next thing we got to move is this X. Now, we've already figured out since it's minus X, it's going to go to the other side as a plus X. So my next line, if I don't want to show every little ounce of work, I could just do 10AC equal to -33 plus X. Okay. Now, I'm still isolating A. Okay, so what that means is I need to move this 10 and this C. Now, even though they're not all in the same order, we know it's all multiplying. Okay, it's all multiplying. So what I can do is divide everything by 10C. Okay, and of course that 10 will cancel that 10, this C will cancel that C. So what I have left is A equal to -33 plus X, all divided by, make sure you put it all over in the numerator, 10C. Okay, now go ahead and pause, make sure we copied it, and then we'll go to example 5. Example 5, right here. Okay, example 5 says that I'm going to do negative 14n plus 1 equal to RT minus 4n, just like that. Now, I'm going to go ahead, oh, we're solving for n, sorry about that, we're solving for n. So what I'm going to do first is I notice I have 2 terms for n that I can combine. So let's do that first. So first thing I'm going to do is I'm going to add this 4n to both sides. Just like that. Okay, see what I did? Now, negative 14n plus 4n we know is negative 10n plus 1 equal to RT. Okay, the minus 4n plus 4n cancels out. Now, we're isolating n, so the next thing we need to do is get rid of this 1. And since it's plus 1, it's going to move over here to be minus 1. So my next line is going to look like negative 10n equal to RT minus 1. And of course, the last step is to divide by the negative n. So I've got n equal to RT minus 1 over negative 10, just like that. Okay, make sure you've got that copied down before we go to number 6. And slide this up. Number 6 says AX plus Z equal to AW minus Y, and we're going to solve for Y. Okay, now solve for Y, excuse me, not W but Y. Okay, so what I'm going to do first is subtract the AW from both sides. Now I want you to look right here. These are not like terms. Do not try to put those together. They are not like terms. Yeah, they both have an A, but this one has an X, this one has a W, and the other one they don't match. Okay, so they are not like terms. So what I'm going to write down right here is AX plus Z minus AW equal to negative Y. Now, let's stop right here for a second. We gotta be careful. We know that in front of that Y, that's really a negative 1. So what that means is I'm going to divide everything over here by negative 1. Okay? Now, I can't leave it just like that because we can simplify that. Because I know right here, anything divisible by 1 is itself. Okay? Everything when you divide 1 into it is itself. But when I do a negative 1, I'm keeping this term, but I'm changing the sign because like right here, I have a positive divided by a negative. Well, a positive divided by a negative 1 would be negative AX. Right here, positive Z divided by negative 1 would be negative Z. So I write minus Z. And then right here, negative 1 divided into negative AW, a negative divided by a negative would make it a positive. So my answer could be negative AX minus Z plus AW. Okay? We'll get that copied and we'll go to number 7. Okay? 7 and 8 are very similar but different. Okay, so example 7 is A is equal to B parentheses C plus D, close the parentheses, and we're going to solve for B. Now notice I wrote that just a little bit different this time. Sometimes they will use the word for instead of the semicolon. Okay? Now, I want you to think about what we're saying right here. I want B all by itself. Well, what do I notice? I notice I'm multiplying B by all of that, right? So the first instinct we have to do here is distributed property, but we're not. Okay, this is not a distributed property problem. Since I'm multiplying B by everything right here in the parentheses, I'm just going to divide both sides by everything in the parentheses. So if I was showing the work, I could do this. Just like that. Now, I would know that the C plus D and the C plus D are going to cancel each other out, and that leaves me with B right here. On this side, I'm just going to have A all over C plus D, and since that's the only thing in the denominator, I don't need the parentheses, so I can just drop them off. Okay, well, that problem didn't look like it was just going to be that simple. Okay, so one-step problem. Okay, now, number 8. Example 8 is the same problem, but we're going to solve for a different variable. Okay, so this is example 8 right here. Example 8 says I'm going to have A equal to B parentheses C plus D, just like we did before in number 7, but this time I want to solve for D. Now, this one is going to have to use the distributive property, because if I'm isolating D by itself, notice D is inside that parentheses. I got to break all that apart. I can't have it sitting inside the parentheses and isolate it. Okay, so what I'm going to do first step is the distributive property. So B times C is BC plus B times D is BD. Now you notice that the D is in this one term right here all by itself. So it's going to be easy to isolate. So the first thing I was going to do was to subtract the BC from both sides, just like that. So I'm going to have A minus BC equal to BD. Now, if I'm isolating D, that means I need to divide by B. So I've got D equal to A minus BC all over B. Now, be careful right here. This B and this B cannot cancel each other out, okay? To be able to cancel out a B in the denominator, to be able to cancel out the B in the denominator, every term in the numerator would have to have a B. Well, the BC has a B, but this A over here does not. So you don't have a B there to cancel out, okay? So that is your final answer, okay? Now, make sure you have these notes copied into your interactive notebook. These are the notes that, excuse my bad grammar, these are the notes that you're going to use for your little equation handout sheet and the CED Point 4 SchoolNet multiple choice problems, okay? So you can find those on Canvas, so help yourself. You can got plenty of work to work on.